Assalamu alaikum. This is chemistry 11th, and our today's lecture is about this bonding and anti-bonding molecular orbitals which are formed. Before going through these bonding and anti-bonding as per linear combination of atomic orbitals, I would like to give a recap of this MO theory. As I have told you that this theory was put forth by Hundred Millikan in order to explain the formation of a covalent bond, and as per this theory a covalent bond is formed between two atomic orbitals, between two half-filled atomic orbitals having oppositely spinning electrons, and these atomic orbitals then merge to form then molecular orbitals. And I have also told you the main features of this molecular orbital theory is that just like an atom, a molecule has got its own orbitals which are called as molecular orbitals, and these molecular orbitals, they are quite different from the constituent atomic orbitals. Similarly, the valence electrons belonging originally to the constituent atoms which are involved in this bond formation, these electrons, they are considered to move along the molecular orbitals under the influence of the nuclei of the participating atoms. Similarly, another feature or postulate of the theory is that these molecular orbitals are of varying energy levels in the same way as atomic orbitals in an isolated atom. Number fourth postulate is that that like atomic orbitals, these molecular orbitals are also arranged in order of their increasing energies. And another postulate of this theory is that the filling of electrons in these molecular orbitals, it takes place in accordance with Aubau's principle, Hundo's rule, and Pauli's exclusion principle. Similarly, another postulate of the theory is of this MO theory is that the number of molecular orbitals formed is always equal to the number of atomic orbitals which are involved in bond formation. And the shapes of these molecular orbitals, they are represented by these Greek letters. We have got sigma, we have got pi, and delta. Now, as I have told you that if two atomic orbitals are involved in bond formation, we get two types of molecular orbitals. One is known as bonding molecular orbital, and another is known as anti-bonding molecular orbital. Now, the bonding molecular, as far as this bonding molecular orbital is concerned, it has got less energy than the initial atomic. These are the two atomic orbitals. I would like to show you here that these are the atomic orbital of one hydrogen atom, 1s, having it has got this clockwise spin. Then you have got another atomic orbital from another hydrogen atom with anti-clockwise spin. Now, when they two overlap, they give rise to the formation of two molecular orbitals. One is the bonding molecular orbital, and this is the anti-bonding molecular orbital. Now, as far as this bonding molecular orbital is concerned, this has got a low energy than the initial atomic orbitals, whereas the anti-bonding molecular orbital, it has got high energy as compared to the initial atomic orbitals. So obviously, as per this Aubau's principle, the electrons will occupy this molecular orbital. This is because of its low energy. Now, as far according to linear combination of these, why these two types of these molecular orbitals are formed, that is bonding and anti-bonding. And one more thing I have already told you, that these molecular orbitals, they are polycentric. Polycentric means, that means the molecular orbital, it spreads over the whole the molecule, containing the number of these number of the nuclei of the atoms which are involved in bond formation. So we say that molecular orbitals are they are polycentric, whereas these atomic orbitals, as you already know, they are monocentric. Now, because the molecular orbital spreads over the whole molecule. Now, as far as this linear combination of this atomic orbitals is concerned, we have got, as we know, that two types of molecular orbitals result. One is bonding, and another is anti-bonding orbital, anti-bonding molecular orbital. Now, you can see here is since these they are formed by the linear combination of the wave function, since electrons are in the form of wave. So in a way, we have got crusts and we have got troughs. The positive half that represents the crust, and the negative half that represents the that is the trough. Now, if psi a represents the wave function of this of the atomic orbital of atom A, and psi b represents the wave function of the or we also call it as, and that amplitude represents the wave functions of the two combining atomic orbitals. We have got psi a plus psi b, and of the two these are the two atomic orbitals, or the amplitudes of the two atomic orbitals of the two atoms which are involved in bond formation, and and the molecular orbital wave function is represented by psi or phi. Then the combination, there are two ways of the overlapping of these wave functions of these the two atomic orbitals. When the two electron waves, when they are in same phase, then the combination takes place by addition. You can see here we have got, this is and this is psi a, and we have got, this is psi b. These are the amplitudes of the two atomic orbitals, atomic orbital of atom A and atom, since the two are in same phase. So there is addition of the wave functions, and the resulting wave we can see here, it is that is the this is the psi molecular orbital. It is given by the addition of the two, that is psi a plus psi b. This is when the two waves are in same phase, that is the crust of one overlaps the crust of the other, or the trough of one, this electron wave, it overlaps with the trough of the another electron wave. This is possible only when the two waves are in the same phase. Then there is addition of the wave functions of the atomic orbitals of the two bonding atoms, giving rise to a bonding molecular orbital. So obviously we can see that in a bonding, in case of this bonding orbital, since the electron waves, there is addition of the wave functions of the two atomic orbitals. The electron waves of they add up and result in the formation of bonding molecular orbital. Now in case of bonding molecular orbital, there is high electron density between the two nuclei, and the electronic charge thus holds the two nuclei very firmly together, and the bond formed is very stable. Moreover, since the electron density lies between the two nuclei, that means the repulsion between the two nuclei, it is shielded. So this results in shielding of the repulsion between the nuclei of the bonding atoms. In this orbital, we see the electron wave, it lies on the same side of the imaginary line, that is the line joining the two nuclei, or the internuclear axis. So bonding molecular orbital thus possesses thus formed, it has got low energy. Now you can see here, it is for this reason that this bonding molecular orbital has got low energy. Now when the two electron waves, they are out of phase, you can see here, this is one electron wave, this is atomic, or this is the wave function of wave function of the atomic orbital of atom A. This is the wave function of the atomic orbital of atom B. Now the two waves are out of phase. We can see the overlap takes place between the crust of one and trough of the other. So obviously there will be subtraction of the wave functions of the two. You can see here, this is psi anti-bonding, this is psi a minus psi b. So since in this case we see that the two electron waves, they are placed in such a way, the electron waves in case of this anti-bonding molecular orbitals, or when there is subtraction of the wave functions of these atomic orbitals, wave functions of the atomic orbitals, the two electron waves are placed in such a way that one of them lies above the imaginary line and other lies below it. That means the electron density lies either above or below the internuclear axis, and the portion that is above this imaginary line, it is taken as positive, while as the lower portion, that is the portion of the electron waves, that is the electron density lying below this imaginary line, it is taken as negative. Since these are oriented in opposite direction, the electron waves, they cancel out, and the probability of locating the electron in the region of this overlap, it is practically zero. So when the electron, so since there is no electron, since the electron density in between the two nuclei, so what happens that this results an increase in repulsive forces, and the two nuclei are pushed apart because there is no shielding between the two nuclei, because electron density it lies above and or below the internuclear axis, or above or below the and this imaginary line. So obviously this has the repulsive force is increased, and we see that the antibonding molecular orbital, this is it has got very high energy as compared to the bonding molecular orbital. Now you can see here that I will show you here. This is in case of hydrogen atom, we see that this is one s atomic orbital of one atom. This is one s atomic orbital of other hydrogen atom. Since when they are in the same phase, there is the two these wave functions of the two atomic orbitals, they overlap or and add up, and they result in the formation of a bonding molecular orbital. So this electron density which lies in between the two nuclei, it holds the two nuclei very firmly. Now, in case of anti-bonding orbital, we see, you can see here, this is one atom wave function of this is one atomic orbital, one s atomic orbital of hydrogen, one hydrogen atom. This is one s atomic orbital of other hydrogen atom. Since the two are in, they are out of phase. You can see here, this is positive and this is negative, and in this way the two nuclei they are pushed apart. This is because of repulsion between the two nuclei, since electron density lies above or below the imaginary line. So we see this, we can see here that the repulsive forces increase and the two nuclei are pushed apart, and it is because of this reason you can that this antibonding molecular orbital, it has got very high energy. And you can see, as far as the probability density is concerned, that is given by the square of the psi. Now the probability of electron density, it is given by psi square, and it is not given by this psi, because psi simply represents the amplitude, whereas psi square it represents the probability of finding the electron, that is the orbital. So if we square on squaring this, if we square this molecular orbital on both sides, you will get square of the psi. It will give us you know that a plus b whole square, that is equal to a square plus b square plus 2ab. Similarly, on squaring this, we get psi a square plus psi b square plus twice psi a psi b. Similarly, in case of this antibonding, where the two electron waves they subtract on squaring this, we get psi square is equal to psi a square plus psi b square minus twice psi a minus twice psi a psi b. So since because of the subtraction, or because of the subtraction of these wave functions of the these wave functions of the two atomic orbitals, we see antibonding molecule, this molecular orbital is formed, and it is because of this, there's this antibonding molecular orbital, and this antibonding molecular orbital results. So this is how linear, as per linear combination of atomic orbitals takes place. So as far as this linear atomic combination of atomic orbitals, the combination of two atomic orbitals, it gives rise to the two types of these molecular orbitals. One is the bonding orbital, bonding molecular orbital, and another is the anti-bonding molecular orbital. Bonding molecular orbital results from the addition of the wave functions of the two atomic orbitals, and whereas the anti-bonding molecular orbital results from the subtraction of the wave functions of the two atomic orbitals. Because of this subtraction, we see that the electron density does not lie in between the two nuclei, rather it lies above and below, and the two nuclei are pushed apart, and it has got very high, and this antibonding orbital molecular orbital has got very high, and has got high this energy as compared to the molecular, this bonding molecular orbital. In case of bonding or molecular orbital, we see that it has low energy. The reason is the electron density is very high along the between the two nuclei along the internuclear axis. So this is why anti-bonding molecular orbital has got high energy, and this bonding molecular orbital has got low energy as compared to the initial atomic orbitals. And I have told you that the number of these molecular orbitals formed is equal to the number of atomic orbitals which are involved in bonding. So if three atomic orbitals are involved, then we get three molecular orbitals are formed. If four are involved, four molecular orbitals are formed. If two are involved, two molecular and these molecular orbitals are formed. So this is how a linear combination of these atomic orbitals takes place. This is for today, and in our next chapter I will show you these how the formation of fluorine molecule, chlorine molecule, and oxygen molecule takes place. Thank you very much.